Okay. Back underneath this guy. Gal. I'm short a grommet. I know I have one around here somewhere, I just don't know where it is, so I didn't finalize the line cord yet. I did cut off the two-prong one and put in a ground, three-prong cord. Its chassis is now earthed, and I put a line fuse in temporarily, just kind of tacked it in right here. It's 1 amp, a slow blow, but timed, delayed fuse. And for now, just keep it insulated and with a nice bright color that will remind me that, oh yeah, that needs attention. Now, yes, for right now the line cord's just kind of dummied in there. Excuse me. I also left a pigtail on it over here. Let me get this line cord out of the way. There's a break in the line cord into the amplifier here. Oh boy, how about we put this around like that. It's a pilot light. And the 2 pigtails. I'm going to attach them to this 60-watt bulb just as a ballast for initial checkout. So with these 2 disconnected, I plug it in, give it full 120 volts. It's not going to do anything. And so all the current into this has to flow through this. And as you know, you could start off. I could start off lower, 60 watts. For something like this is I find it pretty useful. Usually, if I don't see any serious troubles, I'll go from a 60-watt ballast directly to no ballast and see if anything smokes. Depends on how much time and money I've spent on the thing, but this, it cost me nothing. So, anyway, I don't want to ruin it, so I'm going to bring it up a little slow. See if the capacitor needs to be reformed. I got a bit my variac here, so I can slowly bring the line voltage up. Voltmeter, of course. What I'll be monitoring is, I don't even care what the input voltage is while I'm doing this so much. I'm interested in what's the DC voltage across this capacitor. All of them inside, there's multiple section here. And what kind of current is it drawing? Is this getting hot? Is that lamp lit up more than it should be without any other tubes in? Nothing should be drawing much current, maybe except for the bleeder string around this power supply filter capacitor and the rectifier itself, if that's what you're using. To start with, I'm not going to be using the vacuum tube rectifier. I'm going to be using a solid state one. I've gone over it in previous videos. It's this beast here. Draws a little bit of power, this light bulb, but other than that, that's it. So pretty much any indication I get from a 60-watt bulb means this thing's drawing some current. And there are times when it really should not be enough to illuminate this much, if at all. Not with this design amplifiers. There's this very, very simple circuit in here. There's nothing without any tubes plugged in it. Very, very little current should be drawn from this. even at full voltage. But we'll find out. If there is, we'll find out why. And sometimes, you just plug these things in, fire them up, all the tubes, everything seems like it's going fine, and the next thing you know, this thing fails. That's a weak link. Actually weaker than the tubes, believe it or not, when they get to be this age. So, let us connect up some stuff and plug it in and see what it does. So, first thing, nothing, no power applied. I want to find B plus, of course, ground. And on these guys, chassis is B minus, ground if you like it. Just pick a nice spot to anchor your clip lead. There we go. That covers that. And B plus. Where I want to go is, let's see, this is the rectifier. Right out of this pin, which should be pin 8. Yep, 1, 2, 3, yep, pin 8. See, they did it right. They put it off of pin 8, rather than putting it off of pin, what's it, 2 here. Sometimes they take it off of pin 2. I hate that, and it almost always shows it when you look at the drawings for these things. I don't have a drawing for this model. No, but it's common circuitry. But they'll often show it coming off of pin 8, B plus off of pin 8. That's what this red lead here is. It comes all the way over here to this capacitor. So I don't need to get down into the capacitor, especially. I'll just come right off of pin 8 of the 5Y3 rectifier. And try not to let that slip off of there. Well, we're not drawing current, so it's not going to get hot. This is covering up open, exposed stuff. Okay, so the meter's tied in. And we should be reading here 0.0 is nothing. Yeah, pretty much. Okay, leave him off for now. Double check this. I suppose that'll work. Okay, these pigtails. I'm just going to clip lead my ballast lamp here into them, onto them, around them, about them. I'm going to put the clip leads on. Close. Now I want to be able to see that too. The pilot. No, we'll just leave it like that. There we go. I can move that pilot light and force it to stay put. Okay, that should work. All right, the tube that belongs in here, like I said, the 5Y3, pinned out the same as these big old 5U4s. I could put one of these in there and it would work just fine. Draws quite a bit more heater current, if I recall right. You can kind of go figure, those 5Y3s are about half the size of this. So I'm going to be putting that in there. But for this sort of thing, reforming the cap if it needs to be, just general checking the power supply section out, pull all the tubes, even the rectifier, and or plug your rectifier in, whatever you got. I mean, if you don't have a solid state, just put your tube in. Put it down in. Okay, so meter on. DC volts. We've already connected it. Pilot light here. Got our ballast screwed in tight. Looks secure. Say D. Okay. Go ahead. The variac is turned off. All the way down. Plug in the amp. Variac on. And we got 0 DC. Okay, good. About where you want it. Crank this up just a little bit. And I'm only watching the voltmeter here. In fact, let me make that maybe a bit, pardon me, clearer. Yeah, let's see. We're only interested really in the voltmeter and that light bulb. Now, the sun's coming in and making that light bulb look like it's lit up. It's not. I will let you know if it happens. So, the variac's turned up to what looks like to be about 5. And we're getting 16 3/4 volts across the first section of this cap. The section of this cap that sees direct raw DC voltage rectified coming from the transformer. Nothing glowing here, and I wouldn't expect it to. 5 volts. You're not going to light one of these up. So, let it sit there and wander about. Bearing in mind there are other sections of this capacitor. It may take them some time to reform if they're going to do it. You just don't want to blow through this. And now I'm going to take this up to the voltage rating of the lowest voltage rating in this capacitor. It's because it's so low compared to the others. This is a 4-section capacitor. 3 of the sections are rated at 400 volts working. 1 section is rated at 25 volts. Well, that section I've already isolated that section from the circuit, and I showed it earlier, put a small modern electrolytic, I think 35 volt rated was it, in there to replace that. I don't know, I really don't remember if I did that replacement simply as a matter of course, which I'll often do with these low voltage rating in a big can with the high voltage next door. I don't know if it was actually a problem with it or if it was just a matter of course. I don't remember. It was probably a matter of course. Meaning I just do that to where these capacitors are in circuit and their close proximity in a can full of random electrolyte. It's just asking for trouble. So it said here, wondering about 17 volts or so. I don't see any jumping up and down. I mean, the line voltage is not regulated, it's just controlled somewhat. So I'm gonna go up to the 25 volts. Keep in mind, even with this, if this amplifier's line input were a dead short, at this input, which is less than 10 volts, you can't expect to see any light from this. So if you're really curious about it, I'm using a 60 watt just as a blowout preventer. If a serious trouble develops, you'll see it, especially when you get line voltage up to around working voltage. But just to have something there, something is good. But you could use a Christmas bulb, Christmas light, something 7 watts, 5 watts, and you begin to see the current flowing, and it does give you a sort of a relative indication of what the current into the chassis is. And if it starts changing wildly without any tubes in it, except maybe the rectifier, you'll know that something isn't right, and it's usually some stinking capacitor. And some of those won't show up until you really get things rolling and heated and warmed up. Some of that stuff will not show up. So you got to get there. Now, there's zero heat anywhere, and I wouldn't expect it. Looks like, well, if I'm reading this right, now it's pretty. This dial on here is pretty close. I'm putting it's 7 or 8 volts into this. The line voltage is 7 or 8 volts right now. I thought it was 10, but no. And we're already up to 26 volts DC on this cat. It has climbed a little, wandered about a little, but that's probably the line voltage doing that. I wouldn't be concerned about that. So, let it sit for a spell. 5-10 minutes maybe. Let's call it 5. Let's boost it up. Let's get a little scary. All the way up to 40. Or thereabouts. 40, let's call it 41. Bouncing about. Yeah, just kind of look at that. Suddenly that takes a nosedive. Either there's a problem with your line voltage coming in, or something in here's capacitor or something is not happy and is drawing current. But even at that, keep in mind this is the output voltage, DC, into this cat. Going into this power supply from the line right now is about, well, I'd call that 15 maybe volts. And I can check that, but take my word for it. So, seems to be happy, 40 volts. Normally I would walk away, go make a cup of tea, let that sit, make a note of what it is. Some while later, maybe half an hour, and come back and look, and it's moved. Never being more than 8-10 feet away from things, just in case. But this is not rocket science. So far so good. Now, the rating of the capacitor we're looking across is 400 volts. We're seeing 40. That's 1/10. I wouldn't expect a whole lot of leakage at that anyway. But if there is very much of it, you'll see it. Another thing you can look at is what's the AC voltage across it right now? At 40 volts going DC across it. Well, this thing's meant to filter ripple. Is it doing it? Is it open? What's the AC voltage across it? Let that settle. I'm seeing it going about from 16 to maybe 20. Oh, there's a 30 millivolts of AC ripple. Now, this isn't telling me anything about the frequency. That could be RF leaking through it, or God knows what. And every time the line voltage bounces a little bit, that is magnified by the step-up transformer that feeds this guy, this cap. So those slight excursions are going to show up here on this particular meter, on this particular setting, in this mode. But it's not volts. It's a few tens of millivolts of AC averaging. It looks like. So I'll go with that. Looks like it has capacitance, at least some. Yeah. Back to DC, where are we? About 40 volts. Yeah, you can see it's wandering around a little bit at line voltage fluctuations. Largely, that's it. Yeah. So I think just let it sit there long enough. So, that's the process. I'm going to bump it up to, let's call it 90 volts. So we just added 50 volts. And as the line voltage fluctuates, you'll notice bigger changes as you increase the variac dial, because keep in mind, this transformer, the step up, is magnifying any fluctuations, any excursions coming in through the line. And when you're doing this, there's no load on this essentially. In some amplifiers, some radios and things, there would be a load, and even if you pull all the tubes, there's still a load on it, assuming there's a rectifier plugged in. In fact, indeed, here there probably is one too, but it's very, very small. You won't really notice any significant current draw until the tubes are plugged into this, and you get some current plate current going. Plate current going. Sorry. So, okay, just drift it up a little bit. I'm going to put it at 100. Okay, there. Line voltage fluctuations notwithstanding, it will stay, hopefully. I'm going to cut this off, and I am going to actually, because I do want this to form correctly, I don't want to overdo it. I went through that a little bit faster than I normally would. Been burned by that, going getting too salty with it. So I'm going to let that sit, power it up, and come back in a half an hour, 20 minutes, and see what's going on. Quick check. Anything getting hot and warm? It just is. What's the voltage? Or drawing current? If I come in here and that's lit at all, I'm going to go, wah! So, let that be for now. See you.